BA, CA, AC, BC, CC. That. W is either a B or a C, so all the states will have the B or a C in the second component. So AC, BC, CC, A, B, BB, BC, CB. Thank you. And thank you for not necessarily making me feel that I'm talking to myself. And now, of course, all of these combinations, so there's a relation. So if you're in BC, you can only transition to CA. So you only have a transition if the second part of speech in the state is the same as the first part of speech in the second state. So we only have an arrow if you go from second is a letter. So A in second position must go to an A in first position. So you don't have an arrow for all the possible combinations. You have only an arrow for those combinations that are consistent. So AA goes to AB because this A has to be the same as this A because of the way in which we interpret. These are the transitions in the HMM. So BA goes to AB, CA goes to AB, AB goes to BA, BB goes to BA, CB goes to BA. And presumably marker A goes to this, and marker B goes to this. Oh, and marker A goes to this one, and marker B goes to this one. Oh, yeah, okay. And then kind of we can put in the arrows from here to here, here to here, here to here, here to here, and so on and so forth. We can fill out all the arrows that actually make sense, that correspond to arrows in the HMM. And now we can run VITRB as before, going left to right, reading up the probabilities from the transitions, multiplying by the emitting probabilities, keeping for each state which is the most likely that led to it, and then once you're at the end, you make a right pass and you kind of pluck out the path that is most likely. So it works the same, except that now you have a lot more. You need to kind of, because the state machine is more complicated, that gives rise to a little bit more complication when you lay out your states for the VITRB algorithm. But modulo that complication, it is essentially the same. Although it does require, kind of in some sense, you knowing what the VITRB is doing kind of inside and out, because it, as this drawing suggests here on the board, it gets complicated to try to think out. All right, all that to say, the long digression to say that this HMM, you can, even though it has, the states look like they're more complicated, and they are, you can still make sense of the VITRB algorithm over it and still extract out what is the most likely sequence through this HMM that corresponds to a sequence of words. I think we can make it work, and I think I'm going to try to get home because at this point I'm curious as to how this behaves, period. All right, if you followed what I've just been doing for the past 15 minutes, then excellent, good on you. You probably don't need to review any of this for the fun. If what I said was entirely mysterious, then well, you certainly want to kind of look up what a trigram HMM is, because for all I know, this is super complicated for no particularly good reason. A trigram HMM is something completely different and much easier. I doubt it, because otherwise you would have just been shown the trigram HMM right from the get-go. The fact that it's an extra credit question suggests that it's a little bit more involved than a bigram HMM. But it might still be more simpler than what I've just tried to reconstruct here. But here I've tried to reconstruct it from first principles, so it has the usual difficulties associated with that.
Are we going to see something like this on the final?
I certainly hope not. No. I'm laughing, but I'm certainly hoping not. I mean, this is just kind of, if you know how the VITRB algorithm works for a standard HMM, this is just what we like to say in the business, the obvious generalization in this context, but there seems to be called elements. But yeah, so I'm curious to, so I'll look it up when I get home, but you should do that as well, like look up what an actual trigram HMM is doing. It is using these probabilities somehow. And this is in some sense the most obvious way to put them in the model is just use them in the model and then just like munch the model around what these probabilities mean. There are probably other ways of using these probabilities to construct an HMM, which is simple. I would not be surprised. But this is a way to do it, and this would be something that you might want to consider for question 4. This is like the kind of thing which certainly is a little bit out there and exploratory. But yeah, stepping back. The question becomes the standard approach that you've seen in class that you've done for part 2 of the homework is use B-gram probabilities, the probability of a part of speech following another part of speech. How do you use that to construct a model and run the Viterbi algorithm on it, and you can extract out from a sequence of words what is the most likely sequence of parts of speech that led to it. The question is, how do you, if you extract out more precise information, and you can think of this as more precise information, how can you use that information? And this is one path towards trying to answer that question, but you have to understand what the question is. The question is if you have more precise probabilities as to what can occur after what, how can you use it to improve your recognition? Right? And as I said, there are many ways, probably. Oh, sorry, I went on way too long, but random stuff. But all right, you're dismissed. We are all dismissed. Let's go and enjoy the first snow. And for next time I want to talk about, I want to review, I certainly want to review the machine learning and NLP. So we're going to review the Viterbi algorithm, review HMM, so kind of do this in the classical way. I am happy to give 10 minutes to kind of refresh quickly our mind as to the kind of thing that we need to remember for the first part of the course, but we certainly don't want to spend the whole time talking about the first part of the course because you have gone through it once and you might just need kind of a quick refresher. And what we're doing before the next section is try to redo the midterm and see if there's any difficulty. So I'll be here. If there's anything that is unclear when redoing the midterm, then kind of ask about it and we can talk about it a little bit further, but this will be a good indication for whether or not something is clear for you.
The format of the next section is going to be like the same as we did before for the midterm?
Like as in me coming up with questions?
Problems, right?
Yeah, that'd be great. I think it would work well. The only thing that might make it not quite possible to do that is depends the extent to which we can do problems on the board and in class that don't take like 45 minutes to do, right?
Well, this type of problems we don't expect in an exam, right? It's only 2 hours.
There is that. So yes, exactly. So I need to talk to Eric to get a sense for what he wants to put on the exam. So he's the one who's coming up in the finals. So I don't have any insider information about that yet. But once I have the information, I'll try to kind of come up with examples in class that will match that.
Right.
Yeah. All right. Hey, if you have any questions, let me know.